Welcome to 10.7 notes for Algebra 1. It is interpreting the discriminant. What the discriminant is essentially is if you go back to your quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And of course, this is based off of the standard form of a quadratic equation. All right, so if we think about our quadratic formula, the discriminant is going to be what's underneath the square root. So that does a couple of different things for you. If you get something under there that is bigger than 0, so in other words, a positive number, you're going to have two real solutions. So in other words, if you throw a ball, it's going to leave your hand, you're going to have a solution there, and then when it hits the ground, it would also have a solution. If it's ever just equal to 0, this is going to be one real solution. If it ever becomes less than 0, or in other words, a negative number, which we talked about a little bit in the past. So if you do have a negative number, it's going to be an imaginary number. So you won't have any real solutions. So, and of course, we talk real solutions. Real solutions are anything that you've seen this year. So it could be irrational numbers. It could be the square root of 5. That's completely fine. That is not going to be a negative number, obviously. So you will actually have a solution there. So something that wouldn't work, perhaps, would be like negative 7. Okay, negative 7 is an imaginary number. Therefore, that has no real solutions. That would be, if you think back about it, a graph like this. Let's say that you made the graph. It never touched the x-intercept or the x-axis. Therefore, it would not have any real solutions. It could be down here as well, but those are the graphs that you don't have a real solution. If you attempted to trace these on your calculator, looking at the 0 feature, you would not be able to do that. Okay, so it says name the number of solutions. We have 3 different problems here. Of course, the equation, again, is based on your standard form of your quadratic equation. So in other words, letter A, well, now I'm going to test this using the discriminant, which, just to remind you, is b squared minus 4ac. And oftentimes you can do this. You'll be able to tell what the solution is without finding an exact solution. You can usually tell if this thing is going to be negative or not if the 4ac is bigger than the b squared. Okay, so let's do that. B squared here, which is 6, would be 6 squared minus 4a, which is 2, and then c, which is 5. Okay, so 6 squared, that is 36, minus 4ac is 40, which is going to give you a negative 4. So the number of solutions on A would be, there's no, of course, our real numbers, and there's no real solutions. All right. Letter B, same kind of deal. We'll go ahead and we'll plug this into your discriminant. Now understand on B, if there's no x value, the b value is going to be 0. So this one here is 0 squared minus 4a, which is 1. And c is negative 7 since it is a minus 7. So on this one, you can already tell what the solution is. It's minus a negative, therefore it's plus, plus. So 4 times 7 is positive 28, which would give you 2 real solutions. Letter C, all right. If we take a look at letter C, again, we plug this into the discriminant. We have negative 12. Of course, that's going to be squared. Now realize, when you put a negative into this and you use substitution, you have to put parentheses, because when you square it, it will become positive. So 4a, which is 4, and then C, which is 9. Okay, so negative 12 squared is 144, minus, if you take 4 times 9 or 4 times 4, you get 16 times 9. Now 16 times 9 is almost like saying 16 times 10. So 16 times 10 is 160, but you have to take 1 16 off since it's 9 16s. So if you subtract 16 off of 160, you get 144. All right, so that's just the process I go through in my head. This one here then would be one real solution. Now, what are the advantages of this? When you, of course, we just learned 4 different methods on how to solve these things. Okay, so how to solve your quadratic form, equations. Okay, the first one was, you actually learned, was all factoring. If you're going to find, say on the first one, if you're going to find, or excuse me, the second one, if you know that there's 2 real solutions, one of the valid ways of solving it would be factoring. Now that one in particular you could not factor, but if you knew there was two real solutions, the majority of the time you can factor the problem. Secondly, we use graphing, which is often in the 21st century the first choice, since we do have the utilization of technology. What you could do there is, let's say we had a very large graph and it was out of our 10 by 10 window and we couldn't see it, all right? Well, if we had no real solutions, it really wouldn't be worth looking for that graph, since you know that it would never intercept the x-axis. The third one was complete the square. Which, again, if you have 2 real solutions, and let's say you come up with no real solutions on complete the square, well then you know you probably did something wrong. Because again, the discriminant tells me that I do have 2 real solutions. And then of course the last one we used on I believe it was Friday, was quadratic formula. Now quadratic formula, you're going to find out, we won't do that this year, but eventually if you have, let's say, no real solutions, you can still use the quadratic formula. You couldn't factor, you couldn't graph to find those solutions. You couldn't, you could use complete the square, but it's a little tougher. And then quadratic formula would be the one that you'd have to go to. You'll come up with imaginary solutions, which are not real solutions. Okay, so what if we had something like this? It says, tell whether the equation 3x squared minus 7 equals 2x has 2 real solutions, one solution, or no solution. Okay, so we'll go ahead and we'll go to this. Now, one of the things I'll point out is the reason it just says solutions and not real solutions is because, again, in this book, they never deal with imaginary numbers. So they assume that you already know that. So here we go. So first off, I'm going to move this 2x over to the left side of this equation. So I have 3x squared minus 2x minus 7 equals 0. Now, you're not actually solving for x on this. You're just telling how many solutions there are. So make sure when you get your worksheet, you look through the directions. And if it just says how many solutions does this have, you don't actually have to find the x values. Okay, so discriminate here. Negative 2 squared minus 4ac. So I can already see that this is going to be positive, but I'll finish it out for you. Negative 2 squared is a 4 minus, and there's a negative here, so I'm going to change that to a plus. So 4 times 3 is 12, and then times 7. So easy way to do that is if you have 12 times 7, multiply the 2 times 7 in your head, you get 14, multiply 10 times 7, and you get 70. If you put that together by adding, you would get 84, all right? So if I get 88, there's definitely 2 solutions, all right? Next example. Example 3, it says find the number of x-intercepts of the graph of y equals x squared plus 5x plus 8. So understand, x-intercepts are solutions. Okay, so essentially when you graph this, you were looking for solutions where it intersected the x-axis. Another way to say these is zeros. So those are three different things you're going to see throughout this book and really throughout Algebra 2 as well, and really in geometry as well. So these are just the different things that these are called. So the solutions are called x-intercepts. They are also called zeros. So in other words, if I replace this with a 0, plug it in to the quadratic formula, and you would solve for x. Here, we're just looking for the number of solutions. So we're going to use the discriminant instead. So I have 5 squared for b minus 4a, and then c, which is 8. So 5 squared is 25, minus 32, since 4 times 1 is 4, and 4 times 8 is 32. So I get negative 7. So since we have a negative number, there is no, in this case, I guess we could be specific to the question, so there's no x-intercepts. And really, if you wanted to check that, to confirm it, you could graph it on your graphing calculator, and you would find that this is not going to intersect the x-axis. Okay, a couple more examples here I can show you. I'm going to go kind of quick through these. B squared here, b squared of course is 10, so it's 100 minus 4a, which is 1, and then c, which is 25. So I can already tell this is going to be one solution, since 4 times 25 is 100, and you would get 0. Okay, so that just means there's one solution. Second one here, we have x squared minus 9x, all right? So if we plug this into the discriminant, negative 9, but it's negative 9 squared, so it would be 81 minus 4a, and then c here would be 0, I'm sorry. So there is no c, so in other words, you do have to include that, and that would make that 0. So this one here would actually just be 81, since all of these would cross off with the times 0, which is 2 solutions. All right? Last one, number 6. If you have that, we have 2 squared, so we get a 4 minus 4a c. Okay, so negative, negative, negative means that's going to stay a minus. 4 times 4 is 16. We get negative 12, so that is no solution. Okay, last one. This one here, it says the Centennial Fountain in Chicago shoots a water arc that can be modeled by the graph of the equation. Okay, so it gives you a model of the equation. It says where x is the horizontal distance in feet from the river's north shore, and y is the height in feet above the river. Does the water arc reach a height of 50 feet? If so, about how far from the north shore is the water arc 50 feet above the water? So there's a number of ways to solve this. So first off, we need to find out if 50 would be a valid solution for this problem. And the way we can do that is to use your discriminant. So what you need to do then is, since y is the height in feet, I'm going to go ahead and I'm going to put 50 in for y. So I'm going to do that. So 50 in for y would give me negative, negative 0.006. It would be x squared plus 1.2x. Now with these numbers, I would definitely have a calculator handy. All right. The other thing is, if we want to know if this hits x, so I'm going to have to erase this, or excuse me, if it hits 50 feet, we need to get the left side so it is a 0. And really that holds true with any quadratic equation that you see, unless we are completing the square. Now this one, once we get to that part, would probably not be a real good idea to complete the square. Now, by looking at this, and sometimes graphs can be deceiving, so don't trust anything without actually doing the algebra. So it looks like for right now that, yeah, it hits it 2 different spots. You don't have to be a genius to see that it's hitting the 50. Okay, but again, looks can be deceiving. Don't always trust the graph. All right, so let's go ahead and figure this out. So first off, I want to do the discriminant, so I'm going to have to move everything over. So I subtract 50 from both sides. I get negative 40 or minus 40 on the right side. Okay, so that puts me in a good position. I can now, I put the decimal on the wrong spot there. Okay, so now I can go ahead, first off, I can test the discriminant. That'll answer the question whether or not it hits 50 feet. So the discriminant will do that for you. The second question then would be, where does it actually hit 50? And we can find that out if it does have solutions by using quadratic formula. So let's go ahead and figure this out. So first part, like I said, go ahead, plug this into your discriminant. So I get 1.2 squared minus 4a, which is negative 0.006, and then c, which is negative 40. So I'm going to use a calculator on this. It makes your life easier, especially when you get some bigger decimals. We would have to do this. We get 1.2 squared, which is 1.44. I know that 12 times 12 is 144. There's 2 decimal spots. That's why I do that. The second part, a little trickier. I would probably just type that in the calculator. Minus, times 0.006 times 40. Okay, you get negative. Oh, I only put the one negative. Okay, so you get minus 0.96. So we do get negative, negative, negative. Now, at this point, I wouldn't even have to solve this any further. I know that 1.44 minus this is going to give me a positive number. So the first question is, does it hit 50 feet? I would say yes, it hits not my finest sentence ever, but I am a math major. There you go. So it says yes, it hits 50 feet, and it does 2 times. Since we did get a positive number here, which is 0.48. So that would tell us that it hits it, and it does hit it 2 times. And again, you probably look at it and say, well, duh, all right? But in geometry, you'll learn next year that, again, looks can be deceiving. Okay, so where does it hit? All right? Well, that's going to be your quadratic formula. So we would plug this into our quadratic formula. The nice thing is we actually have already solved for what's underneath the square root, which is the discriminant. Okay, but we haven't solved for everything else. So we get negative 1.2 plus or minus square root b squared, or excuse me, we had already solved that. So I'm going to put 0.48 all over 2a. Okay, whoops, we have to put the a in. So negative 0.006. Okay, so next part, I'm going to go ahead, I'll take the square root of negative 0.48. We get about 0.69, so I got negative 1.2 plus or minus, not negative, it would be 0.69. Okay, and then we do have 2 times negative 0.006. All right, we get negative 0.01 and 2. Okay, so what this is going to do is, number one, it's going to turn that negative 1.2 into an actual positive number. So I'm going to do that, negative 1.2 times my answer. So you can always hit second answer. All right. Oh, not times. It would be divide. So it'd be negative 0.012. All right. Okay, so this looks like it's 100 plus or minus. This one's going to turn to a negative. Now keep in mind that you really can disregard the negative on the second one because we do have a plus or minus. So a plus and negative would be the same thing as minus negative, vice versa on that one. So we would get both solutions. But I'll go ahead, I'll put the negative in, and we can figure that out as we go. Okay, so this is going to be negative 57.5. Okay, so your 2 answers for where it hits it. Okay, the short end on the left side, we would have to take 100 minus 57.5. All right, so 100 minus 57.5 would give us 42.5. So it looks like 42.5 and then on the right as it goes, it looks like it would hit it at 157.5. So it hits it, and it looks like where it's hitting it horizontally, I would just say at 42.5 feet, and then and 157.5 feet. And now, just a reminder, another way to do that would be to plug that equation into your calculator, and you can go ahead and you can hit second trace, and then you can always trace your zeros. The only thing you'd have to do is put your window in. And if you can do that, that's another valid way to solve this. That concludes 10.7 notes in Algebra 1.